Hello, calculus students and general seekers of truth. Um, let's continue our discussion here on the error bounds of our Taylor series. And yet, before we can even get to that, we have to look at some vocabulary, just so that the the lesson flows smoothly, because there's a lot of confusing terms, or terms that sound alike. Okay, so what I have over here, this is the Taylor polynomial centered at A. Okay. And then I just listed out some of the terms here. I've gone the 0th term, the first term, all the way up to the kth term. So this part right here, we typically call this the Taylor series. And this right here, all the way up to the kth term, we call this the Taylor polynomial. Okay, and we typically abbreviate or denote it T sub k of x. Okay. Now, so that's what we've been doing before. This terminology should be familiar to you. Now, if we look at what's remaining here, this is typically referred to as the remainder. Okay. After k terms. Okay. And we will abbreviate this r sub k of x. Okay. So this is the remainder, also known as the tail, okay, also known as the error. Okay. So in other words, if we were to say that, if we were to use this Taylor polynomial to approximate the series, so with the Taylor series, we can't actually compute the sum of an infinite number of terms. We don't have enough time. We would need infinite amount of time in order to actually evaluate an infinite number of terms. So often it's the case that we're going to pick k to be some number, some finite but large number, and calculate the value of x at that polynomial. And then we want to ask ourselves, what is the error? Okay, so in other words, what is the difference between the approximation and the remainder? So really, the Taylor series, n equals 0 to infinity, f n at a, x minus a to the nth over n factorial, minus t sub k is equal to r sub k of x. Okay, so this is the Taylor series. This is the Taylor polynomial, or the partial sum, and this is referred to as the remainder, or the error. And our goal going forward is we want to estimate this error as precisely as we possibly can. Okay, so we want to say that our approximation, whatever our approximation is, how close is that to the actual answer? Okay, so we want to, in general, our goal is to find an upper bound for r sub k of x. Okay. So we want to know, like, find m such that r sub k of x, the absolute value of it, because we may have positive or negative, is less than or equal to m. So we want to say, look, if I approximate the Taylor series with the Taylor polynomial of k terms, or of the polynomial with degree k, then the error is at most some constant number. And of course, we would like to get this m down as small as possible. So a smaller m here means a better estimation. All right, all the background work is basically done. Now we can proceed.